Alright, today's lesson, it's all kind of linked. There's actually 3 exercises here, 3 E, F and G, and they're all linked together. So they're all about how we will be interpreting a scatter plot. And so these notes that I'm putting up on this while I'm explaining is also linked on the page there. I've put them up there on our lesson for you to do. So Scatterplot says there we've got 2 variables. Our explanatory, we've got 2 variables. Our explanatory variable goes, variable goes there, and our response variable on the vertical. Alright, so what we're doing is we're looking for a pattern, and it's given this name here, correlation. So there's some things that we would comment on, and here they are in the dot point. So direction, is it positive or negative? Is it a line or not? A straight line or not? Is it moderate or weak? And is there outliers? And so that we'll work through those things. Then in the blue there, positive relationship. So if we've got here and we've got something that goes like that, it's a positive relationship, which means that when that increases, so does that. Alright, so in general terms, so first up in general terms, you need to know what they look like, and you need to know these terms. So again, this is in the notes, and on the next page when I go over here. Alright, so here's the various some examples. So the top one there, they're all positive relationships up the top, and so depending on how, and they're all kind of a line, and so depending on how close the dots are to a single line depends on the strength. So on the left here we're starting with a weak, then we go to moderate, and then we go to strong. Positive, because as you go from left to right you go up as well. Alright, and so of course then you can have something that points the other way, like these lots. Again, weak, moderate and strong, but this time because they're going the opposite way, as you go to the right, left to right, you go down. And then finally, down the bottom here, there's some other examples. So if they're perfect relationships, like the 2 on either side are, that will be a perfect straight line, not any little wiggles. And then if it's just scattered randomly, like that middle one, there'd be no relationship. So you need to have an idea of those sorts of things, you know, multiple choice question or whatever. There might be a graph and you're asked for which one would best describe, or which graph best shows. So let's have a look at a couple of examples. So this example here says classify the following scatter plots exhibiting positive, negative or no association. So look at the A one first. So we're starting up here and we're ending up down there. So that would be a negative association. This middle one here, well, depends. Like this one here, we would consider that to be an outlier. So in terms of looking at the association, we would not take that into account. So this outlier, because that, remember, outliers can skew stuff. So if we take that out, like, where does our line go? Does it go like that? Does it go like that? Does it go through the middle? So this one would say has no association. And then the one down the bottom here, again, we start down here and we finish up here. So that one would be a positive association. Alright, so that's in terms of positive or negative. Now this one here talks about the form. And so they're giving you, is it linear or is it non-linear? So again, you've got to do a bit of interpretation here. So with this one here, we start there and we finish up there. You certainly could draw a straight line through there. So with that first one, part 8, we'd be saying, yep, that's linear. Not very strong because the dots are scattered away. It's going to be weak. Doesn't ask about that, but I'll put that in anyway. So that would be weak linear. Whereas this one here, well, we start here, we finish over here, but we go through here. So this one kind of curves around. So this one is non-linear. Alright, so that's just in terms of what it looks like, but you know, nothing, no kind of strong mathematical way of describing things. There is, however, a mathematical way of describing things, and we'll get to that now. Alright, so here it is. This is the mathematical way. It's called the correlation coefficient, and more correctly, it's the Pearson correlation coefficient, and the symbol is R. Alright, so R is used, so whenever you see R, R is the Pearson correlation coefficient. So you need to equate those two things and know those two things. So the Pearson correlation coefficient describes how well things fit the data. So as it says here, it's between -1 and 1. Now, negative would be a negative association, so when you go from right to left you go down, so like in this one. And positive would be when you go right to left you go up, like that one. Now those ones there, those two there, which I'll just take those off now, you can see that those dots are in perfect lines, so they come out to 1 and -1. And so if you've got something where there's no association whatsoever, like this middle one here, R is 0. Those dots are all over the place. And then there's variations. So let's compare these particular ones that I've just put the stars on. As you can see, we go 1, then down here 0.8, down here 0.8, and then over here 0.7, and then down here 0.3. So as you can see, as we move through those things, the dots get more spread out. And it's the same with the negatives, but you know, the negatives, the line that you would put through the negative ones goes in the negative direction. Alright, so the closer to the line, they are the closer to 1. Alright, so again, that's kind of looking at it from just a subjective view. Now also I need to put this up here. Alright, so this little table thing, so some of these things like this table and those diagrams with the R's and the one I did with the correlation, you know, as in strong, moderate, etc., they'd be things that I would be putting in my bound reference to take in with me. Alright, and so see there's some sort of association or correlation or connection, whichever word you like, to use between our terms that we use, like moderate and an R value. So on this scale here, this is our R value, and this one in the middle, of course, that's just the, you know, those subjective descriptions. All right. So there's some sort of connection between those words that we use and the R value. which is all very nice. But again, we haven't really got down to any concrete mathematical way of doing things. So, first of all, before we do that, there are a couple of things that, or three things in particular, that calculation of R, the Pearson correlation coefficient, depends upon. Alright, so here's what we depend on. It assumes the following, and there's the following things there. These things here are assumptions. So the variables are numbers. There's a linear association, so this Pearson correlation coefficient doesn't work for curves. And the other thing is that there's no outliers. Now, these limitations here, as it says, I've already mentioned, it assumes the following. Assumes linear, I should say. So it doesn't work for nonlinear. And the other thing is it's not reliable if outliers exist, because the outliers, they skew it and change it. So, good news for us, we don't have to do it by hand, even though in your book they show you the formula and how you do it. You do not have to do it by hand, because you have your calculator in both of your exams. So your calculator can do it. Now, I gave you a handout a couple of lessons ago about how you use your calculator to draw the scatter plot. And that's the one it was. And so on the second page of that tells you about this regression thing and how to find R, the Pearson correlation coefficient. All right. So when we do that, we can then get some numbers out of it, and we can make some sorry, I'm just looking at the exercise. So the exercise is just about using, first exercise 3F is just about using your calculator to find the R value. Now, once you've found the R value, because we want to know whether these two things are connected or not. And so once we've found the R value, it tells us how close the dots are to our predicted line, but we'd like something a bit more, again, more concrete. So there's another thing very closely related to the Pearson correlation coefficient, and that is a thing that's known as the coefficient of determination. I'm sorry about the blurred bit of that. It must have shook when I took a photo with the iPad anyway, but don't forget these notes are also on the link for today's lesson, which is on our compass thing for today. So coefficient determination is very closely linked to R. In fact, it's R squared, so it simply is R squared. And we use it to comment on the association or correlation of one variable to the other. Now, this is important, we cannot assume one variable causes the other. Alright, so we can't say X causes this to happen to Y, because that's a very definitive statement, and we would have to know absolutely 100% that that's what it was. And generally that's not the case. But what it does is shows a proportion of variables from one to the other. So you can say that a certain percentage of the variation may be able to be explained by. Alright, so let's have a look at an example. Alright, so this is an example, and that'll explain as to why, illustrate as to what I mean. Alright, so we've got some data giving number of police traffic patrols on duty and the number of fatalities was recorded. Correlation coefficient of R equals negative 0.8 was found. Calculate the coefficient of determination and interpret its value. Alright, so R squared is simply the R value, negative 0.8, being squared. And that, of course, is 0.64. Alright, so 0.64 somehow connects things. And so what are we connecting? What are we connecting here? So we've got the number of fatalities and we've got the number of police traffic patrols. So a certain percentage of the variation in, now of course which one is the EV and the RV? The thing that we change is the number of traffic patrols, and the RV response variable is the number of fatalities. Alright, so then where I was about to go is that this number 0.64, we think in terms of 0.64 as a percentage is 64%, so 64% of the variation can be explained. How do you write that? This is how you write it. Alright, we can conclude that 64% of the variation, alright, so that, and the number of fatalities can be explained, alright, important, can be explained by the variation in the number of traffic patrols, and the remaining 36% by other factors. And you might come up with some such as days of the week or hours of the day. That wording and phrasing is extremely important because we don't want to use terms like this shows, this proves, this whatever. So we need to, because it only explains a portion of the variation. So this next bit of wording that I'm going to show you is extremely important, and this wording you should use at all times. And if you use this template, you should be right. If you deviate it and decide to use some other words, then you could be in trouble. You know, if you start to say this causes that, then you will be in trouble. Alright, so here it is. Here is the way you should write these things. So it says, in general, we can conclude that a certain percentage, the R squared, of the variation in our response variable, and this bit here, can be explained by, alright? Don't say can be shown or causes, can be explained by. Very important that you could say that can be explained by, because remember there's only a certain percentage here, it's not 100%. Can be explained by the variation in our EV, explanatory variable, and the remaining percentage, and remember it's got to add up to 100, can be explained by other factors, and then you would just give an example. Use that wording. I cannot stress enough, use that. That goes in your notes and in your your notes, your band reference that you're taking. Know where to find it, because that's what you need to use. If you use that, you will get 100% on that bit. If you start using other words, particularly when you say this causes this or this proves this, you're in big trouble. You won't get it. Alright, so I think that's it for the moment. So on your work plan, this is the work for the theory, I should say, for exercises 3E, 3F and 3G. Alright, so you can have a go at that, get started on those.